Welcome back to The Explainer. All right, today we're diving into something that sounds, well, almost impossible. It's an engine that could totally flip the script on how we think about power. We're talking about a machine designed to run for more than a decade, non-stop, without any maintenance. Yeah, you heard that right. Let's get into it.
So let's just start with a really big what if. What if you had an engine that could run for over 10 years straight with zero maintenance? I mean, think about that. You turn it on, and you just walk away for a decade. It sounds like something straight out of sci-fi, right? But the tech that makes this a reality is here, and we're going to unpack exactly how it works.
Okay, first up, let's talk about that number, 100,000 hours. That's the mandated operational life, and it's maintenance-free. To put that in perspective, that's 11.4 years of non-stop 24/7 operation. I mean, no oil changes, no swapping out filters, no overhauls, nothing. You just let it run. It's basically designed to be the ultimate set-it-and-forget-it power source.
All right, next number, 76.7%. That is its actual thermal efficiency. Now, what does that even mean? It means this thing converts almost 77% of the heat it gets into usable electricity. That is insane. To give you some context, that's 95% of the theoretical maximum efficiency that the laws of physics even allow. So we're talking about an engine that is just about as perfect as physics will let it be.
And the last big number here, cost. Thanks to some really smart design choices for mass production, the cost to build one of these has been cut by over 75% compared to where they started. So let's recap, right? You've got an engine that runs for a decade with no upkeep, it's almost perfectly efficient, and now it's actually affordable to make. So the real question is, how on earth is any of this possible?
Well, the secret isn't some brand new, out-of-the-blue discovery. It actually lies in a super elegant piece of physics that's been around for a couple of centuries. But it's been given a massive 21st century upgrade. The secret ingredient? It's called the Free Piston Stirling Engine.
So the Free Piston Stirling Engine, or FPSE. The first thing you need to know is that this is not like the engine in your car. There are no explosions, no internal combustion at all. Instead, you just heat it from the outside. You could use solar, nuclear, pretty much any heat source you want. That heat makes a sealed-in gas, in this case helium, expand, and then contract. And that simple back and forth is what moves the piston. That's it.
And it all works in this really clean four-step cycle. You heat one end, the gas expands, and bam, it pushes the piston. Then that hot gas moves over to a cold end, it contracts, and that pulls the piston back. Heat, expand, cool, compress, over and over and over. It's a continuous loop that generates power super efficiently, and get this, with almost zero vibration.
But, if it were that easy, we'd have had these for ages. To get from that cool 200-year-old idea to the crazy performance numbers we just saw, well, that took some serious modern engineering magic. There are a few key breakthroughs that make it all a reality.
It really comes down to a perfect storm of innovations. We're talking about next-level materials, like a body made from a single composite piece and special metals that can handle insane temperatures. Then you pair that with some really sophisticated tech, like magnetic bearings to control everything and super powerful magnets. It's this whole cocktail of tech that really kicks the performance into a whole new gear.
Okay, this right here is a huge piece of the puzzle for reliability. Think about a normal engine. It's got welds, seams, joints, and those are always the weakest spots, right? They're the first place things are going to fail. So what did the engineers do? They just got rid of them. The whole high-pressure part is made as one single, solid piece. By doing that, they've literally engineered out the most common reason for failure. That's how it stays sealed for a decade.
And this is my favorite part. It's the secret to that crazy long lifespan. The piston, which is the only big moving part, never actually touches anything. It levitates. It just floats in the middle of a magnetic field. No contact means no friction. And no friction means nothing ever wears out. It's brilliant.
So all this fancy engineering is great, but what's the real-world payoff? What do you actually get from it? Well, you get its single biggest advantage, a ridiculous amount of power in a really, really small package.
Let's just look at the numbers, because they really tell the story. Okay, say you need 60 kilowatts of power. A typical diesel generator that does that, it's going to weigh up to 800 kilos. A gas turbine is a bit better, maybe 250 kilos, but this Stirling engine, just 120 kilograms. It's just not a fair fight. It's in a totally different class.
And when you see it on a chart like this, the difference is just wow. It's so clear.
You're getting more than double the power for every kilogram compared to a gas turbine. And compared to a diesel generator, it's 5 or 6 times better. This isn't just a small step up. It's a massive, fundamental jump forward.
Okay, so who cares? Why does being super light and super powerful actually matter? Well, it matters because it opens up a whole world of possibilities, things that were just too difficult or flat out impossible before.
Think about aircraft. In aerospace, weight is everything. Every single gram counts. So if your power source is lighter, your whole plane can be lighter. And what does that mean? It means you can fly further, you can carry more stuff, and you burn less fuel. Those are like the holy trinity of aviation.
And if you think weight matters for planes, just wait till you get to space. Launching stuff into orbit is wildly expensive, and the cost is literally calculated by the kilogram. We're talking thousands of dollars for every single kilo. So having a power source this light and this powerful, it's a total game changer. It makes space missions cheaper and lets us build way more ambitious things out there.
Now let's go underwater. For ships, and especially for submarines, it's not just about the weight. Remember how I said the Stirling cycle has almost no vibration? That means it's incredibly quiet, like ghostly quiet. And for a submarine, being silent is everything. It's a huge tactical advantage. This engine can basically erase the sound that tells everyone where you are.
Okay, but let's talk about the elephant in the room. Money. All this advanced tech has to be expensive, right? And yeah, the upfront cost is higher than a regular generator. But if you zoom out and look at the total cost over the engine's entire life, the picture looks completely different. So let's put it head-to-head with a gas turbine over that 100,000-hour lifespan. First, fuel. The FPSC is so efficient it uses more than 50% less fuel. That alone is huge. Then, maintenance. The turbine needs constant, expensive overhauls. The FPSC, pretty much zero maintenance costs. And here's the kicker. To get to 100,000 hours, you'd have to buy and replace that gas turbine 5 times. 5! All while this one just keeps on running.
So what does this all boil down to? It means all the money you save on fuel and maintenance is so massive that the engine pays for itself in less than 5 years. After that, for the next 6+ years of its life, it's just pure savings. It's an investment that pays you back, big time.
So when you put it all together, the insane efficiency, the incredible reliability, the power density, you realize this isn't just about making a better engine. This is bigger than that. It's a technology that makes you step back and ask a really fundamental question. Is this the start of a whole new way of thinking about energy?